All right, our video today is going to be on compound linear inequalities, but this time with special cases. So just to review, a disjunction problem uses the word or, and conjunction problems use the word and. For disjunction problems, any of the shaded regions is going to be part of your solution. And for conjunction problems, we're looking for an overlap of the graphs to determine their solution. So unlike yesterday, we're going to be working with two different sets of graphs. However, I'm going to do the first two sets floating, and then my final answer is going to be actually on the number line. And you're going to see why in a little bit. So there's going to be huge distinctions between the word or and the word and. Okay, so let's just graph it first and see kind of what we're dealing with. So the first one says x is greater than 3 or x is greater than or equal to -5. I'm going to graph each one separately just so you can see what this looks like. So let me go ahead and graph the first one. X is greater than 3. You know how to graph this. And again, we're going to float these graphs at first. Okay, so on the top, I'm going to go ahead and circle the 3. Since there's no equal sign down here, I'm not going to shade it, and I want the x's that are greater than 3, so that's going to go to the right. That takes care of my first floating graph, and then the other graph is going to be x is greater than or equal to -5. So underneath it, I'm going to float it down here. I'm going to circle the -5 because that's my boundary point. I'm going to shade it because there's an equal sign down there, and I want the x's that are greater than -5, so that's going to go this way. So how do I want to interpret this word or? Let me go ahead and highlight the word or. Or means I don't care if you got shaded on the bottom or if you got shaded on the top. As long as you got shaded on the top or on the bottom, it's going to be part of your set. So essentially what we're going to do is we're going to put these two sets together. What that means is as long as the number got shaded somewhere, it's part of your answer. So for example, -9 did not get shaded on the bottom, it did not get shaded on top. So it is not part of your answer, okay? -7 didn't get shaded on the bottom and it didn't get shaded on the top, so it's not part of your answer. -5 is part of my answer because it got shaded on the bottom. I know it didn't get shaded on top, but it doesn't matter whether you get shaded here or here. As long as you got shaded somewhere, you're part of the answer. So -5 got shaded, it's part of my answer. -4 got shaded, -3 got shaded, because all these numbers got shaded down on the bottom. What about 5? Well, 5 got shaded on the bottom and on the top, so for sure it's part of my answer because it got shaded. So we're going to kind of mesh these two lines together and say my overall answer started at -5, including the -5 because it got shaded. And all my answers are going to be this set in the middle. Because it's like those two sets put together, if that makes sense to you. I'm going to go ahead and highlight this in green just because I use the word or, and I know that means put the two sets together. Let's try another one. I have x is less than -7 or x is less than or equal to 0. Remember that or means that we're going to put these two sets together. Let me go ahead and start doing my floating graphs. The first one is x is less than -7. So -7, here's the -7. I want my x's to be less than that. My second one says x is less than or equal to 0. Here's 0. I'm going to shade it. And I want my numbers to be less than or equal to 0. Again, the word or means I don't care if it's on the top or if it's on the bottom. As long as it's somewhere, it is fine. So that -10 got shaded twice on the top and on the bottom, so it's definitely part of my answers. -8 got shaded twice. -7 only got shaded once. It did not get shaded on the top because it's empty, but it did get shaded on the bottom, so it's part of my answers. -4 is part of my answers because it got shaded on the bottom. -1 is part of my answers. It got shaded on the bottom. 0 is part of my answers. It got shaded on the bottom. However, the number 2 did not get shaded on the bottom or on the top, so this is not part of my answers. So it looks like if I put these two sets together, then it's going to end over here at 0. It actually started way over here at -infinity. This is my combined answer when I put them together because I use the word or. For the next one, again, we're using the word or, which means we're going to put these together. Let's see what this looks like. I have x is less than 1. Here's 1. I'm not going to shade it because there's no equal sign, and I want the x is less than 1, so I'm going to the left. Or it's greater than -5. Well, here's -5. I'm going to circle it. I'm not going to shade it because there is no equal sign, and I want the numbers that are greater than -5, so I'm going to the right. Again, I don't care if it got shaded on the bottom or on the top, as long as it got shaded somewhere, it's going to be part of my answer. So -10 got shaded on the top, -7 got shaded on the top, -3 got shaded on the top and on the bottom. All of these are answers because they got shaded somewhere. 0 got shaded on the bottom and the top, so it's also part of my answer. 5 got shaded on the bottom, so it's part of my answer as well. In fact, it looks like all of these numbers got shaded somewhere, either on the top or on the bottom. So when I put these two inequalities together, I'm going to get everything. Every single one of these numbers got shaded somewhere. So my final answer is going to be all of the numbers. And I don't know if you remember, but if you have everything colored in, we say that all real numbers are your solution. And if you want to get fancy, you can also write all real numbers like this. It's a double R. I'll do that again because I know some of you guys are going to be curious. You're going to write a stick and then another stick, and then you're going to make an R out of that. Okay, so that means all real numbers. All right, and then moving over to example number 4. I got x is less than or equal to -6. Well, here's -6. I'm going to circle it. I'm going to shade it. And I want the numbers that are less than or equal to -6. So I want the numbers to the left. Or x is greater than 3. Here's 3. I'm going to circle it. I'm not going to shade it because there is no equal sign underneath that inequality right here. I'm missing that inequality equal sign. And my numbers go to the right. Now, again, we're looking for, as long as it works here or here, then we should be good. So this got shaded on the bottom, it's good. This got shaded on the bottom, it's good. This got shaded on the bottom, it's good. The -6 works. This 4 did not get shaded anywhere. This is not part of my answers. This -1 did not get shaded. This 2 did not get shaded. The 3 did not get shaded, but the 4 did. The 5 did, the 6 did, the 7. So these are my answers. In fact, 3.5 got shaded, 3.1 got shaded, 3.01 got shaded, but 3 did not. So when we put these together, what I'm going to end up with is a graph that has two parts to it. It has the part on the left, and it has this 3 and on to the right. Remember that 3 is not part of your solution set. I use the word or, which means we put these two things together. And this is my final answer. Okay, so we saw plenty of examples when we had the words together, right? When we use the word or. What about when I use the word and? And means that it has to work for this one, and it also has to work for this one. So this means if I want a solution, then it needs to work for both. This is really, really difficult to do as far as being part of the solution. I'm going to do ands and pinks because that's different. That means it needs to get shaded on one side and it needs to be shaded on the other for it to count. So let's show you what that looks like. I'm going to have x is greater than 3. The first part's going to be the same, right? We're just going to graph x is greater than 3. And I'm going to graph x is less than or equal to -5. I'm sorry, x is greater than or equal to -5. I started going the wrong way. Now, how is this different? This one, when I use the word and, it means it needs to be shaded on both of them in order for it to be a solution. So for example, I know that these aren't solutions because they didn't even get colored, right? But take a look at -2. -2 got shaded on the bottom, but it did not get shaded on the top. It needs to work for this one and for this one. So because it only worked on the bottom, it didn't work for both. So 0 technically is not an answer. Neither is 1, neither is 2, because 2 only got shaded on the bottom. It needs to work on the bottom and on the top. 5 got shaded on the bottom and on the top, so 5 works. 6 got shaded on the bottom and on the top, 6 works. So does 7, so does 8, so does 9, so does 10. What about 3? 3 got shaded on the bottom It did not get shaded on top because it got that empty circle, so 3 does not work, but 3.5 does. 3.5 got shaded on the bottom and it got shaded on top. So does 3.1, so does 3.01, but 3 does not work. So we're going to do a 3 with an empty circle, and all these numbers on the right got shaded twice. I'm going to go ahead and shade this in pink. When you do this, you're not putting them together, okay? What you're doing is you're seeing which ones got shaded double time. All right, let's take a look at the next one. I got x is less than -7. Here's -7. I'm going to circle it. And I want the numbers that are less than -7, so that goes this way. X is less than or equal to 0. Here's 0. I'm going to shade it. And it's going this way. I want the numbers that got shaded twice. So let's see. Right here, this got shaded top and bottom. This got shaded top and bottom. This got shaded top and bottom. This did not get shaded top and bottom. It only got shaded on the bottom, did not get shaded on top. So we're not going to count the -7. And it looks like the rest of these only got shaded once. It got shaded down here, but it did not get shaded up here. So -2 doesn't count. -3 doesn't count. -5 doesn't count. It looks like the only ones that count are all the way up to -7. Don't include the -7. The -7 did not get shaded twice, and all these other numbers did. So what did I forget? I forgot to highlight the word and. Forgot to highlight this. And means it needs to work for both in order for you to be a solution. All right, x is less than 1 and x is greater than -5. Let's see, x is less than 1. Here's 1. And it's going, x is less than 1. That's this way. X is greater than -5. Here's -5. And it's going this way. Remember, I'm using the word and. And means it needs to work for both. So I'm looking at the numbers that got shaded twice. Well, -5 doesn't work, but -4 does, -3 does. All these numbers got shaded twice. All the way up to 1, but don't include the 1. And all the way up to -5, but don't include the -5. Remember, the -5 did not get shaded on the bottom. That's not what I meant to do. The -5 did not get shaded on the bottom. The 1 did not get shaded on the top, but all the numbers in between did get shaded twice. So we're going to go ahead and highlight those. And then on the last one, we're going to go x is less than or equal to -6. Here's -6. I'm going to shade it because there's an equal sign, and I'm going to shade to the left. X is greater than 3. Here's 3. I'm going to circle it, and I'm going to shade it to the right. I guess I should have done that on the bottom, huh? I mean, it doesn't matter, but hey, on this one, look at the numbers that got shaded twice. Well, there are no numbers that got shaded twice, right? Like this number only got shaded on top, but it didn't get shaded on the bottom. So nope. And then this number got shaded on the bottom, but it didn't get shaded on the top. So nope. And these definitely didn't get shaded. So there are no numbers that got shaded twice. What do we write? We say that there is no solution. If you want to get fancy with it, you can also write it like this. You're going to put those squiggly brackets and then a line, a 0 with a line through it, saying, nope, there are no answers to this set. Okay, so that takes care of the front side. Sorry, I forgot to highlight. The word and means it needs to be shaded on both. And I can't highlight my solution set. There is no solution set. And so we're done with that. Let's go ahead and move on to the back. Backside is just practice problems from what you've done before. It's exactly the same thing. We're just putting everything together now, okay? So I want to graph 2x minus 5 is greater than or equal to 3, but I can't because I don't know how to graph that. And I'm using the word or, so I know that I'm going to be putting these two sets together. So as long as it got shaded on the top or if it got shaded on the bottom, it's going to be good. So what do? Well, I make it so that I do know how to graph it. I'm going to get that x by itself. I'm going to do that by adding 5 to both sides. I get 2x is greater than or equal to 8. And I'm going to divide both sides by 2. I get x is greater than or equal to 4. I can go ahead and graph that. X is greater than or equal to 4. Here's 4. I'm going to go ahead and circle it. I'm going to shade it. And I want the numbers that are greater than or equal to 4, so I'm going to go to the right. Same thing with the other one. I don't know how to graph that, so I'm going to go ahead and solve for x. I'm going to subtract 4 on each side. I get x is less than or equal to 3. And I'm using the word or. Oh, I'm sorry. Let's see. X is less than or equal to 3. Here's 3. I'm going to shade it. And I'm going to go to the left. Now, this one is very, very tricky. Just because it looks like everything's colored in, but it's not. Remember that we're looking for the word or, so as long as I got shaded on the bottom or on the top, it's good. So that means this one's good, it got shaded on the bottom. This is good, this is good, this is good. As long as it gets shaded here or here, you are good. So or means I'm putting them together. So this works, this works, this works, this works, this works. Hey, even the 3 works, even the 4 works. So when I say everything is not colored, yeah, we might have a little problem there, because which ones are the numbers that are not colored? 3.5 did not get colored on the bottom, and 3.5 did not get colored on the top. So there is a gap. Anything between 3 and 4, in between here, did not get colored. 3 did get colored on the bottom, 4 did get colored on the top, but all those other numbers did not get colored. So what is my answer going to look like? It's going to look like, starting from the 3 going this way, starting from the 4 going this way, you have that little gap in between. And that takes care of my first problem. Let's take a look at the second problem. I got 2x minus 7 is less than 11, and negative 2x minus 9 is greater than or equal to negative 11. Again, we're using that word and. And means it needs to work for both in order for you to consider it part of your answer. I don't know how to graph 2x minus 7 is less than 11, so I'm going to go ahead and add 7 to both sides. 2x is less than 18. Divide both sides by 2. I get x is less than 9. So x is less than 9. Let's see. Here's 9. I'm going to circle it. I'm not going to shade it. And it's going to go to the left. The other one, I'm going to go ahead. Ooh, be careful with this one. We're going to add 9 to both sides. I get negative 2x is greater than or equal to negative 2. We are going to divide both sides by negative 2. When you divide by a negative, that sign needs to flip. So this is going to be x is less than or equal to positive 1. Remember, that sign changes when you're dividing by a negative. Divide by a negative, you need to switch the sign. So the other graph is x is less than or equal to 1. X is less than or equal to 1. Well, let's see. Here's 1. I'm going to shade it. And I want the x's that are less than or equal to it. I am using the word and, which means I'm only looking at the ones that got shaded on the top and on the bottom. So let's see, this one got shaded top and bottom. This one got shaded top and bottom. This one got shaded top and bottom. This got shaded top and bottom. The one got shaded on the top and it got shaded on the bottom. So it does work, but the 2 definitely does not. The 3 does not. The 4 does not, because it's only shaded on the top and it's not shaded on the bottom. So it looks like my answers are going to go all the way up to 1. Going this way. I'm going to highlight that in pink. Okay, what I want you to do right now is I want you to go ahead and press pause on the video. Try this out on your own and then see if you can get the correct answer. I am going to go ahead and play pause on my video. I'm going to, the next time you see it in about 5 seconds, the answers are going to be up. So hopefully you try this on your own and see how you did. All right, here is the answer. The only thing that I'm kind of worried about that maybe you might have made a mistake is right here. Right here, students tend to think, you see what I'm dividing? I got that negative and I'm dividing. Sometimes students think that we need to switch that symbol. Remember, you only switch the symbol when you're dividing or multiplying by a negative number. And here, I'm dividing by a positive 3. I know the top is negative, but who cares? We're saying, what did you divide by? You divided by a positive 3. You do not change that symbol, okay? So the rest of the answers look like this. Hopefully you came up with the same answers, and if not, go ahead and check my work and see what you did differently, and hopefully you'll be able to find your mistake. Thanks for watching, and as always, if you have any questions, please feel free to ask.